Hello Gyanies, welcome to Gyanvah. In today's video, we are going to understand three very important networking concepts, DHCP, DNS, and NAT. But instead of directly jumping into definitions, let's understand these concepts using a real technical example. Imagine you just connected your laptop to a Wi-Fi network, and you want to visit a website like www.google.com. Now something very interesting happens behind the scenes before the website actually loads on your browser. Your device and the network perform several steps automatically, and three important technologies work together during this process. First is DHCP, Dynamic Host Configuration Protocol. When your device connects to the network, it needs an IP address to communicate with other devices. This IP address is automatically assigned using DHCP. Next is DNS, Domain Name Services. When you type a website name like google.com, your computer does not understand domain names. It only understands IP addresses. So the system uses DNS to convert the domain name into the correct IP address of the server. Finally, the NAT, Network Access Translate. Your device has a private IP address, which cannot directly communicate with the internet. So your router uses NAT to translate your private IP into a public IP address, allowing your request to reach the internet server. So the complete flow looks like this. Connect, Wi-Fi. Then, DHCP assigns IP address. Then, user enters website name. Then, DNS resolves domain name. Then, router performs NAT. And at last, request reaches internet server. In this video, we will understand each of these technologies step by step and see how they work together to help us access websites on the internet. So let's start with the first concept in this process, which is DHCP. Whenever a device connects to a network, it needs an IP address to communicate with other devices. Instead of manually configuring IP addresses for every single device, networks use DHCP, which stands for Dynamic Host Configuration Protocol. DHCP automatically assigns important network information such as IP address, subnet mask, default gateway, DNS server. To assign this information, DHCP follows a process called DORA. Here, D stands for discover, O stands for offer, R stands for request, and A stand for acknowledge. Let's understand this step by step. First, when your device connects to the network, it sends a DHCP discover message to find a DHCP server. Next, the DHCP server replies with a DHCP offer, suggesting an available IP address. Then your device sends a DHCP request, asking to use that offered IP address. Finally, the DHCP server sends a DHCP acknowledge, confirming that the IP address is now assigned to your device. Now your device has an IP address and can communicate within the network. Now let's move to the next step, which is about DNS. You open your browser and type a website name like www.google.com. But computers do not understand domain names. They communicate using IP addresses. So your system needs to find the IP address of this website. This is where DNS, which stands for Domain Name System, comes into play. DNS works like the phone book of the internet. It converts a domain name into an IP address. For example, www.google.com will be known as 142.250.183.14. When you type a website name, your device sends a request to the DNS server, asking, "What is the IP address of this domain?" The DNS server then responds with the correct IP address of that website. Now your computer knows which server to contact. Till now you get IP, gateway and all for your laptop using DHCP, and IP for your domain name using DNS. Now comes the final step in our process. Your device now wants to send a request to the internet server. But there is one more problem. Inside your home or office network, your device uses a private IP address, something like 192.168.1.10. This private IP addresses cannot be used directly on the internet. So before your request goes to the internet, your router performs NAT, which stands for Network Address Translation. NAT converts your private IP address into a public IP address. For example, if your private IP is like this, 192.168.1.10, then the translated public IP will look like this 49.205.xx.xx. Now the internet server sees the request coming from the public IP address of your router. When the server sends the response back, the router again uses NAT to deliver the response to the correct device inside your network. Let's recap what you have learned through a flow diagram. Whenever you open a website, this is what happens behind the scenes. Device connects to Wi-Fi. Then, DHCP assigns IP address. Then, user enters website name. Then, DNS converts domain to IP. Then, router performs NAT. Then, request reaches internet server. These three technologies work together to make internet communication possible. So in this video we understood how DHCP, DNS, and NAT work together when we access a website on the internet. If you found this explanation helpful, make sure to like the video, comment your thoughts, and share it with other Gyanies who want to learn networking concepts. And don't forget to subscribe to Gyanvah for more technology concepts explained in a simple way. Thank you for watching.